Okay, hello, welcome to my talk. Yeah, the story of BASIC. And first, small announcement. If you haven't so far realized, this is the talk where you learn nothing that you could use at your work or wherever. So completely useless knowledge. But this kind of knowledge is something that actually I'm interested in, and I want to share it. Because some of the things is like, this is all you can read more or less in Wikipedia or with some links. Nothing really special here. But it's still kind of interesting, and I think some of you will learn facts that you've never heard before. Facts that still affect a world we live in. So, yeah, about me, quickly, I work for a digital asset company, which is behind the language, which is, let's say, Haskell for smart contracts. I work mostly nowadays with Scala and Haskell, in the past with Java, C++, and tons of other Pokemons. Let's say simply, I've seen things. But this is not about me, so this is about really important persons in our industry. But let's start with you. How many years do you code in Java? Like, who is coding like more than 3 years? Raise your hands. Like, yeah? Well, most of you. And more than like 5 years? Raise your hands. Oh, still tons of you. That's actually, you are like quite seniors right now. More than 10 years? Wow. Wow, this is amazing. Like 10 years with mostly one language, but 15 years. Oh, yeah. And 20 years. Okay, I've been working with Java in 2020. Now I don't really code Java, but I every day see a little bit of Java. So I would say I still count, yeah. Okay, so this is amazing, but like I've seen 2 Yaroslavs here. This says something. If you are Yaroslav, you are quite persistent, stubborn, and you stay with the things. I just say that's observation. Okay, so the question is like, is Java here to stay like almost forever? Like, can you imagine that in 20 years, like for some of you, in 20 years you'd mostly do the same, or maybe a little, yeah. Okay, so because let's observe one story, like BASIC in around year 1980. And actually for me it was 1990, but in 1977 when they were introduced like those microcomputers that revolutionized the way like regular people work with computers. This is like Commodore PET, Apple II, and TRS-80. And those machines were, the most important features of those machines were they were having BASIC interpreter ready to use. Like you would code in BASIC from the moment you start this machine with power on this machine. And people, like teachers in school would teach BASIC in 80s, even at universities, like that would be the language that it's very likely if you are not even in computer science, but you are in something about computers, you will learn BASIC. And engineers would use BASIC a lot to do some simulations, like not really only like computer scientists. Those would actually not use BASIC that often, but regular engineers to do just stuff, simulate. But when I look at the world like 2020 something or even 2010, where is BASIC? Like it was so everywhere this 40 years ago, or even 30. But then it's gone. It's not really that. There is in .NET Visual Basic, which is still alive. It's doing okay-ish. But I would say it's not a thing anymore. It's kind of like mostly disappeared from our business. As I say, some people would kill me if I say the BASIC is dead, because there are like probably 100,000 of users of BASIC applications still. I haven't really found really good numbers. I've seen tons of statistics in internet. I tried to pursue some of them, but basically it's always a problem what you actually count, and especially how to compare statistics from 80s with currently. There are some even nice presentations like popularity of languages, but numbers behind, I don't want to present them because those are really shady. But surely you observe that it kind of disappeared. I would say this disappeared mostly in those years. Like in 1995, you would still hear everywhere is BASIC. In 2005, you would just mostly not hear about it. Yeah, okay, so the question is, what has happened? What has happened that something so mainstream has basically disappeared? Okay, but I will start with the beginning, and I will not teach you BASIC today, but I will show some funny things. So this is BASIC in a few lines. Does everyone understand what those lines do? Okay, take a moment. Like, who doesn't understand? I know it's tricky. Raise your hand. So everyone understand. Like, please raise your hand if you understand. Like, majority of you understand what is here. I know it's horrible. It's GOTO there. We'll get to that. But honestly, I would say this is the language that everyone, after a moment, understands. You don't have to even be a software developer. This is more or less the first lines of BASIC I saw as a, let's say, teenager, and I more or less instantly understood what's going on here, not having idea about programming before. This is the idea of BASIC. Yeah? So it was created at Dartmouth College by those two scientists, Kemeny, the teachers, let's say, and Kurtz. For instance, those are interesting figures. Kemeny had a Hungarian origins, and he was working with Manhattan Project in Los Alamos, with von Neumann, for instance. But then he, at Princeton University, was exposed first time to the computers as well as Kurtz, and they did some observations. First, at that time, like university or a bigger institution would have one mainframe computer somewhere, and you would have access to it. Like, those guys literally had like one shift, I mean, let's say 8 hours every 2 weeks. I mean, if they wanted to code something, they would wait this probably potentially 2 weeks, go to this machine in their designated shift with piles of punch cards. They would just insert into the machine and wait for the result. Mostly the result was error, because they were initially coding in assembly machine code. So mostly there were only errors. If something was going wrong, you were getting the result. From the result, you were trying to deduct where was the error. You waited 2 weeks, and again. And quickly they understood that even though everyone preferred that the solutions are in assembly, assembly is so error-prone that you would rather, for instance, stick to the way slower Fortran programming, because in the end, you were actually getting results faster because you were exposed to errors for a shorter time. Your program was more likely to be correct. And they found out that programming is fun, that actually programming shouldn't be only for, and at that time there were teachers at Dartmouth College. And they realized that it would be actually funny if everyone could program. Like everyone, not only scientists, mathematicians, though for those people were exactly like machine code Fortran created, but that should be a thing that everyone can use. For instance, in biology, chemistry, you want to run some simulation, you should be able to write simple programming, something so simple that everyone would understand. And that's the idea for BASIC. So, and one particular thing they had at that time, this college got the machine, which was actually very untypical and not quite popular General Electric machine, because at that time the mainframes machine, the computers were mostly from DEC companies, so PDP or IBM, and General Electric wasn't that popular, but it plays a role in this story. And they created BASIC for this machine. What is also important, BASIC and actually also operating system, and those two things were kind of tight, coupled. So when you were like working with this computer, General Electric machine, you were actually instantly, your operating system was to some extent BASIC. And that's it. It is said that first program is actually, this is expression, let's say, and a statement in BASIC, print 2 + 2, just a story, and the meaning of the BASIC beginner all-purpose symbolic instruction code. Oh, boring. But what is BASIC as a language? You see some really notable things like 9 numbers, keywords, arithmetic operations, and variables. And you have like typically int, float, string, and arrays, and that's it. No like types, records, anything fancy. Just this. And so the point of BASIC was that it was targeted. Let's do it for everyone. Not mathematician, no scientist, not computer science, everyone. And that was it. It actually really got attention. And people started to like it, that regular students could actually learn programming and thought that programming is fun, and I could use this, for instance, in not only for computer science and mathematics, but for instance for biology or some studies associated with society and stuff like that. So this was a hit. But the point is, like, at that time, the world is different to what we... If something is really even great and popular at one university, other university has other computer, other operating system, and teachers, professors there have their own programming languages. So BASIC was there, was spreading slowly. There were publications, it was known to be fun, but it would never gain actually a popularity as it gained if something else didn't happen. Do you recognize those two young gentlemen? You probably heard about them. Who? Yeah, this is Bill Gates and Paul Allen, around 13 years old, 14. And what are they doing? They sit not in front of computers. They sit in front of one computer, which is actually somewhere else in other room. And they are connected to it via teletype. So the machine that was basically looking like a typewriter, you would type things, and there was a printer, and basically, if you enter a key, it would be sent to a computer like an input, and if the computer sent something, you would get it printed, more or less. And they were connected to the machine. So basically, this is in the Mothers Club founded basically access to computers and those teletypes for the school they were learning. And what is important here, the computer that they were connected to was General Electric. And because it was General Electric, it had BASIC. So those two guys were exposed to BASIC very early, and they loved it. So, and then they started business. Do you know how the company that Bill Gates and Paul Allen created is named? Yeah. Yeah, exactly. They created a company called Trafo Data. Yeah, that's a very famous company. Probably you've never heard about it. It's like, okay, honestly, this is kind of, they wanted to create a company that was about measurement of some traffic data, but it never really never went anywhere. Like this is you don't talk about Trafo Data. We don't talk about it. But they were attending the Harvard University, still slowly starting to do the business, and one day it's said like Paul Allen has seen this magazine, this particular cover, like Popular Electronics, and it's really famous right now, with this picture, first mini computer, like for a great price, available to everyone, Atari 8800. And they instantly knew this is the thing, because the world is changing. Now everyone would be able to have a computer at home and do something with it. Okay, so what was this machine actually? I love it. So it had Intel 8080 CPU, which is very important here. So one of the earliest CPUs, and yeah, this is predecessor of the CPU that more or less originated the IBM PC, that generation before, 8086. And this Atari was created by MIT's company, which was basically doing some funny stuff for hobbyists, rockets, radio stuff, not exactly computers, and I bet you never heard about MIT's. Because they basically created one computer that was very successful and nothing. It's like those, music bands that create one hit and they disappear. More or less same happened with MIT's. And it had incredible amount of memory, 256 bytes. Yeah, not kilobytes, not megabytes, 256. And it was really fun to play. I know, I would say we don't have time for it, that I will do it anyhow. Like, you want to see cringe, I bet. So I will try to program Altair, okay? It's, okay, maybe before I do that, this is the code I will try to enter. As you see, this is something in assembly, okay? But honestly, I will be entering on the left because I wanted to show you how home computer looked at the beginning of 70s, 1974. Okay, you would get a manual with that, but most important, now we have to be very careful. This is something that I basically tried multiple times at home, but like 1 of 10 times it worked. So now I'm starting machine. So the odds of success are very likely. Now I'm starting the machine, I reset the machine, and I enter the code. And you do it like that. I put these switches. So this is like the beginning of the first instruction that I deposit in memory, and it's there, actually it's correct. Then I enter the next byte, which is 1. I deposit it. I told you it is a little bit cringy. I deposit the next one. Okay, oh, yeah, I'm here. Now I deposit. You see why the odds of success are not that great, yeah? Okay, now I enter the next byte, which is basically 0. You see, it's it's actually I'm using this 2 bytes here, 3 bytes here, and actually I'm having the octal code, like, because it's so much easier. Like, and that was it back then, that basically you would have this in octal, not in hexadecimal. So I deposit. Did I deposit it? It is the 3rd byte in memory, so I'm entering 4th one. Yes. So the 4th byte, which is zeros, is entered. But actually, I see what was entered here. Only zeros. Now I get to the and there is like 15 of them. I'm really on a good path. And it plays a role because I will tell you, this is important later. Actually, if I fail, that would be even more funny. And I bet, yeah. I already kind of lost. Where am I? Okay. Okay, I would say at least I'm in the correct address. I'm entering the bytes one by one. Okay, this is 1, 1. Okay. That sounds correct. Now I should be in the, okay, now I will be entering this one. Oh, this is now tough byte. Okay, okay, almost there, almost there. I told you there will be a cringe. Okay, no, almost made an error, which would be really not funny, you know, especially debugging this machine. You can imagine how debugger looks like, yeah? It's actually user-friendly. If I make a mistake, I'll try to show it.
Yeah, but we have observability now, yes?
Okay, I misclicked, so it's probably, okay, 0. Okay, this is not bad. Okay, now I have to enter this byte. Sorry, it will be your fault. You stopped me. Okay, almost there. I will be really now surprised if it works, but you know, who knows? There is a chance, like, as I said. And okay, almost made an error again, because, you know, those are assembly instructions, machine code. If I make an error, that would be not like something wrong will be displayed. Nothing will be displayed. Yeah, so I press this, which means actually, and now I run it. Oh, I made a mistake. It doesn't fully work like as I expected, but more or less my idea was to just blink those diodes. Not exactly as it is now. Almost made it, like almost made it. But that was this machine. That's how you would use this Altair. Like that was regular user experience. It's awesome, yeah? Okay. So the thing is, the machine was coming with a really great manual. Just a moment. So you would have a manual for the machine with all the details, what is the logic gate, and then what is assembly instruction, and everything like stacks. And at the end, you would even have, oh, sorry, it's not loaded, but you would have machine codes for every instruction, how to code that, and that's really awesome. So if you had this manual, like this is manual for regular user compared to the manual you typically right now have with your machines, like, yeah, that describe, obviously, typically, where is the web page, yeah, and video. But okay, so technically it was machine for hobbies and some really devoted professionals that knew what to do. I would say this was the Raspberry Pi of its time. You would buy it mostly to pretend that you would do something really cool, but you would just play a little bit and find out it's basically completely unusable. Or you actually have a case, then you buy it and it works for you. But no, that wasn't really for a regular like guy, for regular even like for regular user. So Paul Allen Bill Gates saw this Altair, saw this ad that it's coming. And the third guy was called Monte Davidov. You don't talk about him mostly, but he played important role here. So they contacted MITS, so Ed Roberts, the CEO of this company, and they said that they have a basic for this Altair. We would change the machine for a really usable machine. Obviously, they didn't have it. But they had two things. They had access to Harvard University computer PDP-10, very powerful machine back then, and they had 8008 CPU emulator. But no, not exactly the CPU that was in the Altair, but the generation before, which is exact. So actually, if you look at 8086 processor and Core, Intel Core, they actually originate from this one, 808, very simple processor. And they had emulator of this processor. So actually, what is really interesting, they never get access to Altair. They never had access to this machine. They had only access to emulator. They built emulator for PDP. They had this manual and some additional stuff, because I found out manual doesn't cover everything. There is some important pieces missing, but somehow they got it. And they wrote BASIC in more or less 3 kilobytes of assembly, which is important. Assembly is important, not the machine code. They didn't really write byte by byte. They were writing in assembly, and it was like compiled, assembled for them into machine code, and without access to the real machine. And now comes the question. So they wrote the BASIC, but you should ask, while looking at two important questions. If it was 3 kilobytes in assembly, how can it fit to the machine with 256 bytes of RAM? And second, how you actually code BASIC with the switches? That would be not great, yeah? I bet someone tried. But no, this is not how it worked. So actually, in order to use BASIC and even load it, you needed some expansion. So Altair was actually quite expandable. It was designed to have expansions. It was actually, they originated something like a data bus, central bus in computer. Okay, then maybe actually, okay, there were buses before, but this is like for regular computers. It's even before the buses that we have in IBM PC. It's kind of decided the initial standard. S100 was the name. But the point is that you would insert more RAM, actually minimum 4 kilobytes of RAM, and you would have this typewriter. Actually, the same machine that you've seen on the picture, that they were communicating with this other General Electric computer. But now you could connect this machine to Altair, and you could print characters, and those characters could be received on an input port by the machine. So they coded. And actually here in the middle, you see, here you would insert a punch tape, this one, with holes that you could be read. So instead of you typing things, it could be just read character by the machine. So they did it. And Paul Allen is going, actually, because he is, of the two, he was looking more mature. Like Bill Gates at that time was known for looking a little bit like a kid, not really a serious businessman. So Paul Allen was selected to talk via phone, because he was sounding more serious. And he was having they have organized, actually, I think that the deadline was like 3 weeks. They had like 3 weeks to actually write this BASIC. I don't really remember, maybe 4 weeks, but not much. But they did it. And Paul Allen is almost about to enter the plane to go there to present it with this tape. And then they realize, but how you actually load this tape? Because the problem is, you still have the switches. This machine has absolutely nothing like basic input, output system, whatever. It wouldn't load the tape. You have to code. You have to code the loader. You have to actually manually, with the switches, code the bootstrap that would basically load this tape. So actually, but you know, Paul Allen was smart coder. Bill Gates also. Most of the BASIC is kind of developed actually by Bill Gates in assembly. But Paul Allen did it. He managed, while being in a plane, using manuals and actually manually converting opcodes to machine code to octs, so hexadecimal octal code, actually that was octal. He did it. He made it to the meeting, and not unlike me, because I entered the code, it somehow worked, but I saw there was a bug. He did it without the bugs. You know, in front, the most important business meeting you do with the switches, and the program was way longer than mine. Okay, 3 times longer, more or less. And he did it without error. First, he designed it, and without error entered. Wow, this is something for me unimaginable. And worked at the first time. And actually, then this BASIC that they designed without having access also worked. It printed like how much memory do you have, asked, and then printed ready. And then they entered first line, and it went. And it was like great success. And yeah, that's how Microsoft has started. By the way, we still have code for this BASIC, and it's awesome. So this is machine code, actually assembly code, that with comments that you can read. There is like story how it was, how we have it, and actually the comments don't really come from Bill Gates and Paul Allen, but more or less we have it. And I didn't want to show you how great it is by just looking at opcodes. That would be tough. But look at this. Somewhere in this memory, they have keywords of BASIC. And for, next, if. And you store those as strings. And those machines do not have much RAM. You have to conserve it. So how do you store string? Nowadays, if that was, for instance, written in C, you would separate those things by 0. You could separate it by whatever. Or you could tell in a first byte how many bytes the next instruction has, how long it is. Yeah, that's how you more or less deal with strings, how you dealt on a byte level. But how here, do you see how those strings are here separated? We have hex on the left. Actually, this is a very smart idea. The last letter has a 7th bit, which in case of letter it's of no use, it's just set. So you see that the last byte is always a little bit higher. And that's how they saved like 20 bytes of memory here. And you know, this was actually the thing, because 20 bytes of saved was 20 bytes for BASIC, for the real program, then more, which was the thing. Actually, you were fighting for bytes of those machines, and they fought really well. And it was actually that Microsoft BASIC was known, actually, for being relatively small and to actually not occupy much memory, which played a role here. By the way, this BASIC also had something, this third guy. You remember third guy? I already forgotten his name. But he did one important thing. He convinced and actually was paid for write floating point operations, because floating points is kind of heavy thing, and he wrote it. So the BASIC by Microsoft initial version had floating points, which played a role. But let's compare these strings with Java string, like just jump to nowadays time. How many bytes Java string occupies? So you know, in memory, like you will have object header, because in JVM actually, you have some object header. It actually doesn't have to be 8 bytes. On exactly this particular JVM that I ran, it had 8 bytes. Then you know pointer to the class, like 4 bytes. Then it has hash, 4 bytes for hash. But you know, because if you have a hash code for string, you don't want to calculate it every time. If you calculate it once, so it's initially 0. If you calculate it, it's actually written here. So next time you, for instance, put a string into the hash map, it's not hash code is not recalculated, or you do equal hash code comparison, whatever. The point here, like very lately, I think Java 9 or something, someone realized that sometimes the valid string has hash code 0. So if you store 0, next time it's asked about hash code, it's recalculated again, which is actually was the problem. That was how you could actually do denial of service by just bombarding the system with strings that accidentally had hash code 0. There were even generators of these strings, and even like really normal sentences. There was a generator created, I've seen once, that had normal sentences which all were strings of hash code 0, which was really beautiful. So, so that's why we have this boolean. Like we got this boolean later, which says, yeah, actually hash code is 0 in that case, so don't recalculate it. So next byte, thanks to a good design. Then we have coding, which is 1 byte, which says basically it is Latin 1, so now we save. In the beginning, Java was storing like every character in 2 bytes. Now it's sometimes 1 byte if this is just Latin text. And then we have a, let's say, pointer to byte array. But you know, byte array is also an object in Java, so it has object header with class mark. So to sum it up, empty string in Java consumes on the JVM more or less 40 bytes. Actually, there are things like string and turning, so it is sometimes a little bit less, but it's beautiful. Compare it to the saving RAM in the past. But I don't say Java is bad. It's just different times. We don't have to worry that much anymore. So, but the thing is that BASIC changed Altair 8800 into machine for users. But actually, you had to invest a lot. And also important thing, this BASIC was interpreted. That's how we mostly remember when you hear about BASIC, it was interpreted language, one by one. Original Dartmouth BASIC, which I haven't said, was actually compiled. Every time you would run the code, it would be compiled. Because the language was designed to be so simple that it would be really fast compiled, actually in one pass, which is really important. So I would say even to this, if you look at the BASIC, like people say right now, the closest to assembly is C. or they were like languages closer to assembly. But actually, the closer to thinking how assembly goes is actually BASIC. One instruction, one line, and that compiler, the original compiler, kind of proven this because you could just compile BASIC in one go. No type structure, because come on, now basically non-current processor, because that was different in the past, understand things like a struct. What is a struct? In BASIC, you never had structs, and even like procedure calls, something like this. BASIC didn't have it, just jumps. And that's exactly how I think BASIC somehow, if you learned BASIC, learning assembly, understanding assembly was quite simple, because the idea was more or less the same. But okay, so people were getting this BASIC. Of course, that was actually substantial investment to play with this BASIC, and every time you turned on the machine, you had to actually code this loading procedure again. So it's like regular user would have this teletype, a BASIC, ready, and then initially after start of the machine, play with switches, like entering something like 20 of bytes in order to start playing with BASIC. What a beautiful word, yeah? But the problem came, it was getting popular, but people were actually kind of copying those tapes with BASIC, because at that time thinking, oh, what is the code actually? This is a set of numbers. Actually, code is a huge number. Why would I pay for a number? That would be insane. So people were basically copying this BASIC, just copying the tapes. There were machines for that, and just freely like spreading among themselves. So this is the letter which was had quite negative reception, where Bill Gates says like, you are just stealing. Copying this number is stealing. It is a theft. And the more, if you are into computers, interested in that, by doing that, you're actually undermining your future, because if you are not paying for the software, you as a software developers won't be paid in the future. You have to change it. So, okay, it wasn't at that time that well understood, but I would say there is a point in that. However, when it comes about stealing, now very important part, because Bill Gates and Paul Allen, while actually working on this BASIC, they were using Harvard University equipment, PDP-10, and someone spotted it, especially that it partially, that time machine was really used by different groups, and one of the users was also, like, it was somehow, Department of Defense was involved, so it was a huge thing that someone saw that this is used for private purpose, even worse, Bill Gates was a student, so actually, it was like in a shady area if he can use it for private purposes or not. But letting Paul Allen touch it was really beyond the border. So there was a small investigation, and what has happened? Actually, nothing. So there I have heard different legends about it, that Bill Gates was forbidden to use the machine anymore, which probably is true, but nothing more serious was done against him for the exchange that this BASIC version was given to university. But basically, we don't really know, because that was probably I have never seen a real good document about it. So, but more or less nothing happened. But let's say this practice was a little bit evil, and that plays a little bit important role later. So, however, BASIC becomes popular with Altair, and then comes, but this is still quite pricey machine. 1975 comes this CPU, 6502, and the world is changing. So, and Bill Gates meets Jack Tramiel. So Jacek Szmiel, by the way, of Polish origins, Jew, actually a Jew, that was for a moment in Lodz ghetto, then survived Auschwitz camp, and then built a company from scratch, Commodore, doing mostly electronics calculator in the States. So really tough and experienced person, and he started negotiating with Bill Gates, which means that ended well for Bill Gates. Actually, Jack Tramiel is known for saying business is war. That was his approach to negotiations. So, and at that time, Bill Gates was still a young software developer, full of ideas. So the deal was like Bill Gates wanted like $3 per machine, not that much with BASIC, but he got 25,000 for like life license for all the 6502 CPU machines that Commodore sells. Commodore sold 12 millions of Commodore 64 and some millions of other machines, like, wow. It's like worst deal ever, actually. It at that time wasn't known, but let's say this machine started the Commodore PET, actually entered the market in 1977, 78. And 78 was very tough year for Microsoft. They barely survived. This money like only was enough for a few months, and they were like struggling, financially struggling, which plays important role. So, by the way, those machines were actually ready, contrary to Altair, where you had to load type. Those machines had actually ROM. So here is actually the chip with ROM code. So you start the machine, and you have the code. And then we actually, but you know, a funny story here, like. This is no, we don't have time for this. That's why I'm going to anyhow present it. So this is Commodore PET, and at one version, Microsoft was so angry at Commodore that they did this. If you enter this, by the way, completely useless instruction. By the way, those machines were never saying that the BASIC by Microsoft. Here it's Commodore BASIC, and it was also popular practice, like white labeling. You never ever it was known that it was Microsoft, although people in the business knew, but if you enter this, you get this. That was the revenge of Microsoft. However, and someone in Commodore spotted it, so they had to retract it, but it's and anyhow get to the market. The biggest point was they were not actually angry for writing this Microsoft. They were angry that this costed like 7 bytes of ROM. It was, but those machines were at that time having like 4 kilobytes of RAM and 8 kilobytes of RAM. So then comes my machine, the first one I used, Commodore 64. I quickly try. We don't have time for it, so I'm going to actually show it. Show demo of BASIC, just a moment. So this is Commodore, and I won't type a BASIC because we don't have time for it. But I load it from the disk. Actually, disk initially was something that you wouldn't have. This is a code, and I will first run it, and then I'll explain what it does. So this is like the very bad version of Snake. I don't even use, I don't have a joystick to play with it. It doesn't even listen to joystick, but slowly it will grow and it will just go there. So honestly, it was very easy to create the Snake. But let's see the code. You see that the colors have changed, and I just present first few lines. This plays an important role. What those magic numbers mean. So actually back then the BASIC had only limited numbers of keywords, like 20 keywords. But among them was, for instance, command keyword poke, means store in this address in memory this value. This value is of color 0, and this is the address where the color of this border is. So I could actually, by the way, 0 is not like it's an RGB. I can, for instance, color 7 is yellow. So now I have yellow border. And then this magic number here means like print, special character, which means clear the screen. And all of that was like this. Look, here are arrays. I don't want to show you, like, most important, like when you list it, at the end you have tons of GOTOs. I love them with passion. Like GOTO, GOTO, GOTO. This was really making my code looking like very solid spaghetti, which I loved. And okay, that's it. I don't want to spend time on it. That was a beautiful coding on Commodore. So basically, that was a machine for user. Same for Apple II and others, TRS-80, although it had a little different CPU, but all had like BASIC. So you start the machine, and you have BASIC ready. Like you would just do print 2 plus 2. Oh, moment, sorry, just oops. By the way, it's like maybe I haven't shown you how IDE at that time worked. This is actually very funny. I can go to this place, and maybe now I will use red. I just entered something, and I will list line 2, and you see it has 2 here. So whenever I'm using enter, it just looks what's under this line and potentially stores that in memory as a part of the program. Now if I run, the border will be red. Okay, that's it. So it was also very peculiar IDE. But users get used to that. So life of user was turn on the machine, load a program, save it on tape. Yeah? And quite often, actually, you wouldn't have access to cassettes, mostly because those cassettes, floppy disk were a thing of the future, let's say. You would type it from the books. So there were books, there were magazines with listings. You would, as a user, you wanted to do a budget. Either you create the program on your own because you already know BASIC, or you type it from the book. Or you type even the game from the book. That was the era, but we go back a little bit like this 975. And you know, to recognize this person, also the next important person in this story. Steve Wozniak. Yeah. So he is family name is of Polish origins. Actually, his family is like all over the Europe, but finally he landed in States. And he was attending a homebrew computer club in Palo Alto, where he saw Altair 8800, and he saw that Bill Gates become like celebrity because he created this BASIC for Intel. So he wanted to be star, the computer programming star as well. When he saw that 6502 processor is coming, which the most important thing about 6502, it was very cheap, so he knew this would be next revolution, like processor and machines for everyone. So he wanted to be the first to build BASIC for it. And he kind of did very quickly. But you know, the thing is that he didn't have access to PDP-10 on university and nothing like that. He didn't really have any fancy computer. So he coded his BASIC in machine code. Really just translating the byte, like he was writing on a paper and coding the bytes using the book. So his basically whole BASIC, which is also like few kilobytes, was all done on paper with machine code, then entered in machine. So he actually created this machine. So this is not the motherboard of the machine. Actually, so it is a motherboard, but it's also the full machine. That is the first product that Apple was selling. So Steve Wozniak had a colleague, Steve Jobs, you've heard of him, and both decided they will be selling this. Actually, the idea is that more or less Steve Wozniak wanted to be famous and created a machine so everyone would see how genius programmer he is. So it was kind of a demo thing. You would get this, you would have to build a case for that, a keyboard, connect it to the monitor, like everything. But the motherboard was for $666.66. And that was it, Apple I. Actually, at that time, it was just called Apple. And yeah, one thing about this BASIC, it was like, actually it was the first for 6502 as far as we know, but it was because it was coded quickly and in machine code, it didn't have support for floats, which plays a role. So then the next thing that Apple created as a company was Apple II, and it was actually the full machine in '77 with a keyboard, monitor, and everything, and it still had this integer BASIC by Wozniak. But people were asking, actually, oh, come on, no one can do a serious business on this machine because BASIC only supports integer. Because you know, when you calculate real dollars, like money, you obviously use float. Who knows that you use floats for that? Yeah, I don't know what was in minds of those people, but that was what people were thinking in the 70s. You do calculations on money, you use floats. And by the way, no, if you use Microsoft BASIC, you even count to, you do this typical count at 0.1 10 times, what you would get? Actually, you would get displayed 1, but it is not 1, actually. But if you do, for instance, 1,000 and add it 1,000 times, you would get the very visible floating point error. So yeah. But still, people somehow thought, yeah, it's a great idea to count money and do any business with floats. So kind of demanded. The problem is that because this was BASIC done by the honest man with honest pen and paper and machine code, not stealing time from a university and using assembly, it was hard to extend it. And Wozniak basically quickly lost interest in that. That was a nightmare to even fix a simple error. And Wozniak actually, he was a really great engineer, like a genius. So he saw this is the boring task. So he went to the next thing, like designing a floppy disk and stuff like that, where he could be famous again. He actually did that. But yeah, that's other story. So basically, no one was doing this BASIC with floats. So Apple contacted Microsoft, and they made a deal, which wasn't great as well for Microsoft, but actually this deal saved Microsoft. It was something like $30,000 in the worst possible like down of Microsoft. They were like almost thinking that they will not have money for the next month. This deal saved Microsoft, which is interesting because like 20 years later, Microsoft will save Apple, which is like, wow. So the thing. So, and then came the IBM PC with, so you know the IBM PC, 1981, actually had ROM with BASIC. It even had support for tape reader for cassettes. Wow. And it had obviously Microsoft BASIC and some newer version, and that's, but by the way, I'm talking about Microsoft, Wozniak, there were tons of companies doing BASIC, but Microsoft played the most important role here, like, and other BASICs were like exactly compared to Microsoft. Even other BASIC were sometimes thought inferior only because they were not exactly working like Microsoft Basic. But the problem is also the next one. Not only each machine has this memory, you remember these pokes, like writing some in memory. So if you had one Commodore machine, you would have this set of pokes. In this address will be the border. In other machine will be something else. Imagine a machine by Apple. You would have completely different pokes. And even worse, the dialects will be slightly different. That was a nightmare. So being a basic programming meant mostly you knew how to code one or two machines, but were kind of useless in others. And then it went even worse because BASIC was evolving. At one moment, people wanted to forgot about line numbers, have labels. Wow, that was awesome. Have Visual Basic with forms, have procedures, local variables, forget about GOTO. So basically, GOTO is still now in BASIC, but you don't have to use it anymore. Actually, you can now write, even in the middle of 90s, you could use BASIC without GOTOs. And you could actually use BASIC, compile BASIC, because now there were compilers. Yeah, so BASIC really evolved. So this is like, let's say, modern BASIC from Wikipedia. I don't even recognize this as BASIC, like, wow. But it is to this point. Like, the modern the BASIC was, the more diverse and it was like a hell, like, what does it mean even to be So now we're finishing it. So, did BASIC really die? So, Microsoft still supports it, but it's surely not popular. That's the thing is. And there are other languages, like COBOL. Did COBOL die? No, it's used in legacy. But yeah, no one sane is trying to be COBOL developer, okay? It can happen to you, like many bad things can happen to you in life, but you don't really try to be on typically. Okay, I tried, but it didn't work. But there are but COBOL was very popular in state on this machine. Then we have Fortran Algol. Also, but basically, Algol, you would never hear about it. Fortran, still, you would see some Fortran code, but it's kind of dead as BASIC. But the difference is that BASIC was really mainstream. BASIC was like ruling, and now that's different. So what killed the BASIC? Yeah? What do you think that killed BASIC? You have ideas?
Python.
Python killed the BASIC.
Technically, BASIC is still used in the Excel.
Okay, yeah, it's there, like my Visual Basic for applications. Yes, it didn't die totally, but why it disappeared? That's one good question. I would say, although it started to die just before Python came. Okay, we don't have time. Let's say my ideas for that. I tried to read a lot about it. Like, first, it was always considered slow, even if you had compilers. BASIC was known to be slow, which didn't have to be the case, but it was considered. Now these dialects. This never helped BASIC. From the beginning till the end, the multiple dialects of BASIC incompatibilities was killing this as a language. Which, by the way, that's why Sun Microsystem was so furious when Microsoft started to do changes in Java. If you ever heard about J++ story, they wanted to not have the same story as with BASIC, that you have different types of Java that are not compatible. And then there was this guy, who is it, that said horrible things. Like, it really struck me when I was the basic programmer, when I heard about, GOTO is harmful. Oh my God, this is the most beautiful thing I've seen in my life. Like, I can jump anywhere. Like, what you're saying, man, you know nothing about computing, like Dijkstra. But that was my first thought when I heard about it. But then I was doing some bigger basic programs, and I thought maybe there is something in that. Maybe. I remember I was... But the biggest point is, this is actually associated. It's just not trendy. You just don't go with your colleagues to, to the city and say, I am basic programmer. You wouldn't, it's nowadays you wouldn't say, I am PHP developer. No. It's you can tell it to, I don't know, someone, but not to the other people. We don't say it. Even if you are a PHP developer, you don't say it openly. So that's how, more or less, that happened with BASIC. But this is, for me, most important reason, I think. But actually, the success of BASIC was that it was designed for regular users, not for the programmers. And this is actually the reason for its downfall. Because at that time, it was OS, shell, IDE. You wanted to do something with computer, you had to use BASIC. You were kind of forced because there was nothing there. But now we have other things. We have spreadsheets. The things you would do in the past with BASIC, now you do with a spreadsheet. For instance, you want to calculate decimal into hexadecimal. You have a tool, or you go to the web page which does it for you. Previously, you would write it in BASIC. Then same with Shell, Bash, Python. Python, yeah, it's replacing. So basically, it just got replaced with just tool designed for the job. So no one actually has to code, especially the first two things, because. So once the users have something to replace, there was no need for BASIC anymore, mostly. Can it happen to Java, do you think? Yeah, so I would say that thing cannot happen to Java. Java is designed for developers. What I think is Java is designed so that humans write it. The thing what can change, maybe humans will not be coding in the future. You know what I'm talking about. We don't say it, but maybe there is a language that will be designed BASIC was for users, Java is for developers. Maybe there is, let's say, for our success, people machines that will succeed us, there will be a better language for them. And Java will disappear. I don't know. I have no idea. This is just guessing. So that's my story. Thank you. And do we have some time for questions? There were any questions? Moritz, sorry, I just look at Slido. There are questions. Oh, Slido, okay. Pirates of Silicon Valley. Okay, there was this movie, I think, yeah? Yeah, I watched it. Oh, yeah, and there was about Excel. So I showed, Excel, I think, to some extent, killed the BASIC, although in Excel you have BASIC. Actually, in OpenOffice you have also BASIC. Not many people know it, yeah? Oh, well, not really. How about microcomputers in Poland, like Mera 400? Okay, honestly, I know about this machine, I read a lot, but I couldn't compare it. The BASIC, particular very interesting BASIC for me is something called Warsaw BASIC, but that was extension of Microsoft BASIC for Commodore 64. It was actually very crazy, BASIC that was supporting loading parts of program and storing, having kind of a swap and stuff like that. So they were but yeah, this is completely other story. So I don't know about those BASIC and can't tell much. Yeah. Okay, so thank you very much.